What up, gamers? Oh, I meant, hi, everybody. It's a video lecture for business calculus, and we're doing 9.4 derivatives. Okay, so you're finally getting to actual calculus, and it's so refreshing. But not yet. No, we got to do it the long way. So, no, it's fine. So, what is a derivative? It is the same as your slope. And I'm going to put of a tangent line. And let me give you just a quick demonstration of what that looks like. Let me start over. No. And yeah, that's fine. So about right here. That's a great spot. So tangent lines are a line that's only touching at one point. And it could even be something like right here where you get like something that's flat. There you go. So those are tangent lines, and they exist all over the place. The slope of that line is the derivative. And I'm not going to try to graph what the derivative of this thing would look like and all that stuff right now. That's not the point. The point is that we're going to have to do it numerically, and you're going to have to remember that slope is y2 minus y1 over x2 minus x1, okay? I don't know where you come from with the math, but I'm going to do that. I'm going to show you that. There we go. Before we keep going, because I'm going to do some actual derivatives here. Like, I'm looking ahead, and I see that we have to do them a little bit. So, it's something about trying to do it the long way all the time. I don't know. Anyway, so I got to show you some basic examples of this thing called power rule. Now, I'll give you a whole lot more of these rules, I think, in the next section. But power rule is really, really important. It's kind of like where we're going to use like most of the time. And so let me give you the formula for it. If you have a y is equal to x to the n power, the derivative, and let me make sure you're understanding some notation. This is called y prime. That's your derivative. Okay, so if you see a little prime mark up there, it means derivative. The derivative of this guy is going to be n times x to the n minus 1. What happened is that this n comes down to the front as like a multiplier, but then you subtract 1 from the power. So I've got to do some examples, right? Let's say that I had x squared. It's a very easy one. So then that 2 is going to come down, so it's 2x now to the 1 power. Now you don't write 1 power, obviously, so just 2x, there's your answer, okay? Let's do some more. Let's say that I had, what do I have here? A cube. So I got cubed. So y prime, I now have a 3. See that 3 is going to come down to the front. And now what's the new power is a 2. Very good. I just literally minus 1 from it every time. Literally just minus 1. And so let's do this last guy here. I'm bringing the 4 down as a multiplier, yeah? So then that's 7 times 4 now, x to the 3. 7 times 4 is 28. So that would be your derivative. This actually, I don't have it written down on my notes here, but this actually works for constants also. So let's just say I had a number like just 5. Just 5. Actually, let's just start with 5x for a minute. So I'm going to take the derivative of this, right? So this is a 1 power, so I'm going to take the 1 and move it down as a multiplier, and then minus 1 from the power. Well, anything to the 0 power is a 1. So 5 times 1 times 1 is 5. And so if you have like just 5 or like a number next to an x, it's just going to end up being that number. Now, what if you have just a number without any x's? What's going on is that this is 9 to the 0. Okay, now this is where it gets a little funky, okay? But it still works. You move the 0 to the front as a multiplier, and then you minus 1 from the power. It still works, because what happens is it doesn't matter about what's going on there. You get 0 times anything is 0. So a constant will go to a 0. Okay, now we're going to mush all this stuff together. Let me actually do one more last example. Let's do 3x squared plus 4x plus 5. Something like that. That's great. And I want to find the derivative. So each component will have its own little mini derivative. So the 2 is going to come down to make a 6, x to the 1. You don't have to write it. This guy is just going to have its number from the front, and then the 5 goes to a 0. So this is your answer, and you're done. That's how you take derivatives. Now, the problem is that the rest of this section forces you to do it the long way. So, and that's very frustrating. Very frustrating, because I just taught you how to do calculus, and they're like, no, you can't do calculus yet. Okay. Okay, I might be overdoing it. So there is some concepts here where the derivative is equal to slope. And that is a very, very important concept. That's the whole reason for doing derivatives. So I really like that aspect of these things, but I think they just overdo it sometimes. So we're just going to do it. And if I see a weird one, I'm going to do it with you, of course. There you go. So they say, that's a 2, by the way. If you can't see, that's a 2. That's a 2. So they give us this thing here, and they say find the slope. And they say find the slope of the secant line in particular. The secant line means that they have 2 points. And they do have 2 points here. It's the 2 and the 1. And the graph of this thing, it looks something kind of like this here. And there's like 2 points. And it's not just 1 point, it's 2 points. They're connecting through the 2 points. They say find the slope of that line. They didn't give me what the function was. Oh, yeah, they did finally. I'm sorry. It's 5x minus x squared. Okay, so I have to plug this in for right here. I'm going to plug in the 2. So then I got 5 minus 2 squared. And then I've got 5 minus 1 squared all over 2 minus 1. I'm just plugging them in to that formula right there, okay? Cool. So 5 minus 4 is a 1, and then 5 minus 1 is a 4. Negative 3 over 1 is a negative 3, and there's your answer to part A. Yeah. Anyways, part B, they say find f of 1 plus h minus f of 1 all over h. And they're going to take the limit of this thing here in a few seconds. So this here is difference quotient. We saw this on the last section, or the section before, I don't really remember. But it's one of those guys. And it is slope. It's the same thing, y2 minus y1, and this is x2 minus x1. Cool, nifty, I guess. Here's the long way to do this problem, okay? Here's the long way. And so I have to take, again, if you remember, you have to remember that this is 5 minus x squared. So I'm taking this, and I'm going to plug it in right here into the x. So here we go. 5 minus 1 plus h squared, okay, minus, and then I'm going to plug in the 1, 5 minus 1 squared, all over h. Awesome. So I need to do a little bit of math here. This one I'm going to FOIL out. And this is calculus. I'm just going to go ahead and real quick. All right, there you go. And then 5 minus 1 is a 4 all over h. Distribute your minus sign. And so what we actually get is 5 minus 1 minus 2h minus h squared, and then minus the 4 all over h. Now notice that this is a 4, and this is a 4, and they cancel. So negative 2h minus h squared all over h. Again, I'm going to cancel one h from each of these guys. Leaving behind negative 2 minus h. That's the answer they're wanting for part B. Okay. Finally, they're saying find the limit of all this stuff. Now, oh man, this is so nice because 0, you're going to plug it in. You plug in a 0 right there. You already got the answer. So plug in a 0, you get negative 2, and that's their final answer. I don't know what they're wanting to go with there. I think it's cool, it's neat, it's like, okay, but whatever, man. Yay, we did it. Next question. So, yeah, the next one is a word problem, and it looks like a big one. Let me just, oh, no, it wasn't that bad. Wasn't that bad. Here we go. So there's a lot of words there. There's 2 hours into a 1,000 kilometer race, and you pass the 66 kilometer mark, so at the 2 hours, and you pass it with a velocity of 38 kilometers per hour. Okay. So what do we do? So part A says find the average velocity over the first 2 hours. It's not too bad, actually. So average velocity, they're trying to say the slope. And so, oops, it's m. y2 minus y1, x2 minus x1. So I need to have these 2 points, of course. Well, if you start the race at 0 minutes, you went 0 distance. And then after 2 hours, you hit the 66 mark. Ta-da! 66 minus 0, 2 minus 0, it's 33 kilometers per hour. So that's the average speed or whatever. I'm going to write average because I wrote average. There you go. Okay, part B says find the equation of the tangent line. So the equation of the tangent line at x equals 2. So what does that mean? I got it wrong. I got to say I went and got it wrong because I just did not know what was going on. They're following this cool little formula for lines. Okay, so it's been a while, but there you go. There's your formula. And we have 66 hour, or the 66 kilometer mark. The speed is 38 at that specific time. We're not using this guy. We're using what we were at that very moment. And then, of course, I have the 2. So we're using that point at 2, 66, and then the 38 velocity that they gave us originally. And literally, this is your answer. You're done. Don't change anything. That was it. Okay. Thanks, Chad. Yeah, you're welcome. Okay, so 9, 4, 37. I think we're actually going to do some calculus finally. Now, I know I skipped a lot. There's a 5 in there. That 5 is actually kind of important. Okay. I know I skipped a lot. I have no idea where we are in the homework right now, but I skipped a bunch of questions because I had already talked about it in the very beginning of the lecture. A lot of those are just little copy-paste problems. This one was different, so I wanted to talk about it. Notice that I'm changing the square root to a half power. That is very important in order to get derivatives, okay? Square roots turn into fraction powers and stuff like that. So then f prime, again, this is my derivative. I'm doing derivative stuff here, okay? The 8 will go to a 0. The 8 goes to 0. The 1/2 comes down to the front. So I got a half now. X to the what power? Now, you minus 1 from the power. So you got half minus 1. If you're confused about what that is, you have 1/2 minus 1 is now a negative half. Thanks, Chad, for showing me. If you kind of mush this together, that's 5 halves, and then we got this negative 1/2 business. Well, the negative means that's in the denominator. So it's kind of like this. Well, the half power means it's technically a square root. And so this is your derivative. That's your derivative. Cool. Then they say find f prime of 1. This is the easiest thing because we already have the derivative. Now they're just saying plug in a 1. So I plug in a 1. What's the square root of 1 is 1. So it's 5 halves total. We're done. I think there's a couple other questions after that that are similar. You plug in like a 2 or a 3 or a 4 or whatever. And well, there you go. You're done. It's really pretty straightforward. Okay. This is a huge problem. Oh my gosh. I only have 2 problems left. But this is like massive right here. Oh my gosh. I'm just looking at it like it took up the whole page. And you can tell I write pretty big, but like still, that's still pretty big. X squared plus x. So it says find the slope of the secant line. So they want slope of the secant line. That means they have 2 points, so that's x equals -3 and x equals a +1. Slope, I know that formula. If I can write it down correctly, that is. Yep, slope formula. So I'm going to take these and plug them in. This is x2, this is x1. So I'm going to just plug those in directly, but here I have to plug them in to get the values. So here we go. I'm going to say I got negative, no. I got a 1 squared plus 1 minus, and then I've got -3 squared plus a -3 all over the 1 minus a -3. Okay. Trying to keep it all straight. So here we got a 2. +9 minus the 3 is a 6. So we got -6 all over 4. So -4 over 4 is a -1. Sweet. So that was the slope of the secant line. Now, they say find the slope between these other points. Okay, so find the slope for x equals -3, and x is equal to -3 plus h. Sorry, I'm just rubbing my fingers because it's like I'm just drawing so much. It's fine. It's not hard. So we do the same formula as last time. I'm going to plug this in as my x2. So I got -3 plus the h squared plus -3 plus h minus, and then we got the -3. So -3 squared minus the 3 all over, and this is where it's a little weird here, -3 plus h and then minus a -3. Now what's happening in the bottom is that this is 2 negatives make a positive. That's a 3, so I can cancel those 2 guys out. That's at least fast. Here I'm going to FOIL it out. +9, -6h, +h squared. If you're thinking, wow, how did you do all that, Chad? I did it with math magic. No, I'm joking. So +9, 2 negatives make a positive, -3h, -3h, +h squared. There you go. So that's what I'm doing. And then over here again, we already did this. This was a 9 minus 3 is a 6. All over just an h, I guess, this time. See how we got this 9 as a +9 and a -3 and then a -6? They all cancel. So that's kind of cool. These combine together to make a -5h over h. And then I got the h squared over h. And again, we're canceling our h's and stuff. So -5 plus h. That's the answer for what they want. Part C! Seriously. Part C, they say, now find the slope of the tangent line at x equals -3. Basically, we're taking this and we're going to plug in 0. I know that that's kind of weird, but this is the actual answer. So why did I plug in h equals 0? If you go back up, it was supposed to be -3 plus h, right? I'm going from this point to this point. And basically, they're saying, no, we only want the 1 point, not 2. And to make these the same point, I would have to say that h equals 0. What happens is that I take my formula for it, I put a 0, and then I get the answer. Okay. So, actually, no, I'm trying to think if there's an easier way. There's not an easier way. Not on the fly. I'll draw something for you, okay? I'll draw something for you. Okay, let's just say I have a parabola, okay? And I have this, and I have another point out there, and this is my secant line, okay? So this is the slope of the secant line. Well, this distance between these 2 points is my h distance. And if h goes to 0, which we actually did the limit as h goes to 0, somewhere around here, right there. We did it right there. We're plugging in a 0 to get a tangent line. So what's going on is my h is getting smaller and smaller and smaller. And finally, I just have the 1 point, because like h is equal to 0, it just kind of eliminates all that. You got the 1 point, and then what you're looking at is a tangent line. So there you go. So it's kind of a cool little progression. The concepts are awesome. I just don't know if that's going to be as important to you in this class. We're more focused on applications here. You're not going to take this into other classes. Well, you're not going to take this on into like further math classes. It's just businessy kind of stuff, right? Your mathy math is going to stop here. At least that's the idea, I think. Cool. So we did it. That's great. And then it says find the equation of the tangent line. This is when it says part D, the equation of the tangent line. Eek, I didn't spell it right. That's the y minus y1 m times x minus x1. And so my y value at -3. Did I ever do it? Oh, yeah, it's right here. This is my y value at -3. It was a 6. 6. My slope is the -5. We just found that. X minus a -3. Two negatives make a positive. Distribute. Add 6 to both sides. 9? 9. There it is. There's your answer. Whew, that was a big one. We got one last question. It is an application question. It's more like physics, but, well, whatever. Not everything can be super businessy, I guess. So there's an object that's dropped from a building, and that's at 576 feet above the ground. And they give us this formula for S, which is its position, 576 minus 16x squared. So they say all this stuff. So they say how long to hit the ground. And then after that, what's the velocity at impact? All right, so you're business people, right? Cool. And you got a cool new job downtown Houston or downtown Austin. It's just some place with big tall buildings, right? And you're going up to the tippy top floor because it's all super cool. And you're like, oh no, I dropped my cell phone. That is a bad thing. Don't have that happen. Okay, don't. That thing is gone. And, ooh. So, like, what does it look like for it to fall? You know, so you got this thing and you're way up here and you're like, oh no. Right? So, here's your formula for it. Let's figure out how this is going to work. So, how long until it hits the ground? Basically, I want this whole position, this is the position of it, I want the position to be equal to 0. I want this whole thing equal to 0. So 576 minus the 16x squared is equal to 0. Solve for x. So I move it over here. Divide by the 16. And I get a 36. Okay, let's prove it, okay? I mean, I know I just did this. I did this on the side. But 576 divided by 16. There you go. There's a reason why we have Desmos up the whole time, right? And so plus or minus 6. And again, this is like seconds. Now, the minus doesn't make any sense, so it's just the answer 6 for that. So 6 seconds later, crash. Now, it was asking for the velocity at impact. So velocity is going to be the derivative. And so I need to find the derivative of this thing. So S prime of this guy, that number goes to 0, and then the 2 comes down. So now you got negative 32, and then x to the 1 power, essentially. And this is the formula for the velocity. What is x equal to? X is equal to 6. Oops. So you multiply the thing by 6. And I know it's negative, but the point is that you get a negative 192, because negative means going down. The answer is 192 feet per second. I think that's a fast. I don't really know. I'm sure it is fast because I mean you're dropping it off like a building. It's gonna be really fast by then. It hurts. We're done with that section. That's it. Thank you very much. Have a great day.